Hi, my name is Eric Cooley, and I'm a co-director with the University of Wisconsin Discovery Farms program, which is part of the University of Wisconsin Division of Extension. And today I'm going to be talking about an exciting project that we've got going with the Antigo Flats Producer Group Partner Project. One of the neat things about this partner project, which we're really excited about, is it really does allow a number of different benefits that we're finding, especially over this past few years of doing this, is that it really allows us to provide these efforts statewide instead of just having those focused around where we have staff available in the county or in the state to do these types of efforts. But probably the bigger thing that we've really found out is that we're having some of the local partners more integrated into the actual collection of the data really has enhanced the kind of the understanding of the data. It's really helped out a lot with little things that were challenges that we're finding at the sites. But really what we were finding out in these last 2 years of data collection is the interpretation. Having those local partners there to really see what's going on at the sites and be able to provide then, some background behind some of the numbers that we're seeing has really been a much greater benefit that we've seen in past years with Discovery Farm staff just collecting this data ourselves. So in the Antigo Flats Producer Group, the main focus of that group is really to evaluate the impact of potato and other crop production on some relatively low pH, high phosphorus soils. And one of the things that you can see in the pictures, most of these are pictures from that first year of monitoring in 2019, but I want you to take a look at that far right photo where, as we're getting into snow melt, you can see the immense amount of snow that this region gets. It's got kind of a little microclimate by the flats where the soils are, as they claim, very flat, but there are hills that surround this flat area, and we see some additional snowfall that falls in this area and almost like a little microclimate, even with some additional rain as compared to some of the areas surrounding. One of the other things that I'd like to point out in that first year is in that bottom left photo, where you can kind of see an ice crust that's formed on those soils. And in this year, that first year of data collection, there was probably a half to almost an inch of ice that underlied this really deep snowpack, which really translate to a lot of the information that we saw in that first year of data collection, especially as compared to the second year of data collection that we're going to go through. So we've got currently two sites, uh, and on site one, it's a 22-acre basin. The first year we monitored, it was coming out of an alfalfa grass mixture, and it was the first year of potato. And then in 2020, this last year, it was spring seeded down again back to alfalfa and grass. Our second site is a 57-acre basin, and that had potato in 2018, and it was seeded down in the fall of 2018. So it was newly established alfalfa in 2019. And in fact, at this site, there was such poor establishment from that fall seeding that it was reseeded again in the spring of 2019. And we'll really see kind of a difference between that first year of seeding and this second year in 2020, where it's been established now for a year. So the first thing we're going to talk about is the annual precipitation at both sites. And we've got this broken up with field year 2019 on the left-hand side, field year 2020 on the right-hand side. I know it's a little bit harder to see as these graphs on the left in 2019 are shaded out, but we've got the frozen amount of precipitation, which has been converted to its liquid equivalent on top, and then the actual rainfall um, on the bottom portions of these graphs, with the 30-year average for this region, with that bar going across the middle. And as those pictures showed, back in 2019, we had a lot of snowfall. So we had just about 6 inches of extra precipitation above normal total. And a lot of that was in the form of snowfall. We really had a deep snowpack last year, or excuse me, in 2019. Whereas this past year, we had even greater precipitation where we were between 9 and 11 inches greater than that 30-year average, but not quite as much snowfall as we've seen in past years, and especially in 2019. But you'll see we had some really large kind of early summer rains that really comprised the majority of the total precipitation that we saw at the sites in field year 20. Now, when I talk about a field year, um, our field year runs from the beginning of October through the end of September. And the reason that we uh, have that time period is most cropping operations are done by the start of October. So any nutrients or things that are going on as far as field activities are really for that next year's crop. So we attribute that to that next cropping year. And as if you look at the monthly precipitation values as we go through the year, we did have a relatively wet October in October of 19. But again, we did not have much snowfall, especially in January and February of 2020. But then when it came into March, we did have quite a bit of snow and some additional kind of sleet and rain as we got into that snow melt time period. Um, and then again in June and July, we saw definitely above average precipitation as compared to those 30-year average bars. So if we look at, this is a graph of all of the individual events and how they kind of rank throughout that field year, we can really kind of point out these or this one date back in July 26th of 2020 where we had some really heavy rainfall in that region. At site one, we had about a little over 4.5 inches, and at site two we had almost 5.5 inches, and these occurred in right around 6.5 to almost 7 hours. So very intense rainstorms that were quite short in duration, and we did see quite a bit of flooding and ponding in the area. I know some areas got even greater amounts of precipitation as you move north, but these storms really were quite large in relative scale, where they at site one were almost a 200-year event, and at site two they were almost a 500-year event. So these were very large rainstorms, but luckily they occurred well into the growing season, and we'll see that these landscapes actually handled those pretty well because of the timing of those very large rainfall events. So now moving on to annual runoff. We saw again with that large amount of snowmelt that we had back in our first year of monitoring in field year 2019, that almost all of our runoff during that year was attributed to snowmelt, and we just saw just heavy water coming off of the land in March. And it was really a combination of a rapid melt, but then I also talked about that little ice crust that was below the soil. And so it didn't allow for any infiltration into that soil profile, and basically all the snow and a little bit of sleet and rain that we got in that March, it almost all came off. And in fact, it was so bad and we had such bad ponding that some of the water that we monitored at site two that year may have come from outside the actual topography defined basin, because there was water laying 2 to 3 feet in depth in some areas. And we do think that at least in that year, some water came in from outside the basin. And that's part of the reason that you see some greater runoff from basin two than basin one in that first year. Now, as we get into the second year, and this is again having those local partners there to help us figure out why we're seeing this is a real head scratcher for me. This data actually just completely flip-flopped with respect to the runoff, and especially how we saw frozen runoff at site one, whereas we didn't at site two, and site two is the one where we saw the elevated frozen soil runoff in the previous year. And, it really comes down to the crop where we had, and this again is thanks to Chuck and James in the area that could shed some light on this, is that we had potato in at site 1 in 2020, whereas we had the second year of alfalfa, which was well established and had a lot of growth going into that winter time period, where having that bare soil from the potato production combined with that melt, more rapid melt because of the radiant heat hitting that bare soil in spring, resulted, we believe, in greater frozen soil condition runoff at the potato site, whereas the deep snowpack that was aided by that standing hay really provided some insulation on the ground to prevent that deep frost formation, as well as really caused a slower snow melt in that second basin. So we had much more of that infiltrating. And so we really saw a distinct difference between those two sites based on the cropping history of those. So some really neat dynamics looking at the runoff between the 2 years and how much of an influence tillage and a standing crop can have with respect to runoff in those different fields. So again, looking at the timing of when that runoff occurred this last year at site 1, again, coming out of potato, and that site did not get seeded down, I believe, until April, with that mix of alfalfa and grasses, is that we can see that a large majority of the runoff occurred at snowmelt at that site, whereas with that established hay at site 2, we barely had any runoff occurring in March. Again, slower melt, and because the frost was pulled out of that soil with that snow blanket, it infiltrated into the soil instead of ran off. Whereas where we get later, again with that big storm on July 26th, we can see those sites, the runoff from those sites being more similar in comparison. Looking at soil loss, we can see that in our first year, again, with the large amount of runoff that we saw at site 2, we did have some erosion occurring in that field, that right as those soils were thawing and some additional rains that we got in spring, we did see some soil moving in that field. Whereas in the potato field, we did not see as much soil movement. Now moving to this year, again, with the new seeded alfalfa, we can see that in that seeding year, until that crop gets established, that we can see quite a bit of soil movement. Now, again, we have got alfalfa or alfalfa mixes in both of these plots this year. It's just that this was a new seeding year where that soil was bare initially as compared to a well-established hay crop. So again, having that well-established hay crop really decreased the amount of soil loss that we saw. And we have seen this in some dairy systems and other areas where we've had that new seeding hay, where that typically is one of our larger runoff, as well as nutrient loss years, soil and nutrient loss years. Looking at some of the details again of when we had that soil loss at site 1, again, it was in that snow melt in March, as well as some of those early spring rains in May and June. Whereas once that gets established in July, when we had those very large when we had that very large rain event, we can see those sites acting more similar once that alfalfa's had time to get good establishment. And one of the things I wanted to point out, and we'll only have one slide like this, where we're really looking at kind of the runoff with the scale on the left and the soil concentration in the water, which is the scale on the right. I want to kind of point out two different time periods here. When we had that snow melt in spring at site 1, we can see that we had a lot of water moving, but our soil concentration was relatively low. You can see those dots very near the bottom. Again, that soil matrix is frozen, and we don't have a lot of detachment and transport of that soil. Second time period is in that late May and early June storm periods where we can see that the concentrations of soil were much greater. Again, that alfalfa crop hadn't really fully established yet, and but the lucky thing is that during that time period, you can barely see the little blips of runoff on the bottom there. So we did not have a lot of water moving. So again, looking at the graph that I just showed you, um, we can really see, again, this is a situation where we had high runoff, low concentration, and these other two are time periods where we had high concentration but low runoff. And we can kind of see how those soil loss values compare throughout those different time periods and those different conditions. So finally, moving on to phosphorus. And this was, one of the reasons that we are targeting some of the research in this area is that these soils are really commonly having soil test phosphorus values in those mid to even high 200 soil test value phosphorus ranges. So relatively high soil, or actually very high soil test, but they are also in many instances running very low pHs from anywhere from the high fours to the mid to low fives, especially during that potato crop production year. And we really think that there's a combination of factors that have resulted in some kind of average to low phosphorus loss values. To be honest, when we came into this area and knowing the runoff that we received and compared to other areas in the state, I personally expected to see much higher phosphorus loss values that were coming from these fields than we did. Again, in the first year, we've got potato production at site 1, new seeding, um, alfalfa at site 2, and we did have quite a bit of soil loss, so we were above the that Discovery Farms median value of all of our sites combined together. But that potato production year was actually below that. And interestingly, we can see the dissolved phosphorus, which are the lighter bars compared to the particulate phosphorus, which is a darker portion of both of these graphs. This year, we can see the new seeding as compared to the established seeding of alfalfa, and both sites were below the Discovery Farms median, even with some decent runoff at both sites and the high phosphorus values. So we're really trying to dig more into some of the pH and maybe some of the other soil effects that are really resulting in some relatively low phosphorus loss, even out of these very high soil test phosphorus values in the region. Again, looking at when this loss occurred between the two sites, we actually did at site 2 saw a little bit of losses from some events in the fall, but at site 1, again, when we saw a lot of the water as well as soil movement, we see a strong correlation between the soil loss and the resulting phosphorus loss at site 1. And again, as we get into that July time period where that alfalfa was well established finally at site 1 compared to site 2, we see very similar losses between the two sites. And finally, moving on to nitrogen loss, following very similar trends with respect to phosphorus, where we saw values that were kind of at or above the nitrogen values that we've seen for our Discovery Farms median. But in this past year, we saw those values were quite a bit lower than those Discovery Farm median values. And much like phosphorus, similar trends for the nitrogen losses at those two sites. Where at site 1, we saw the losses again in that snow melt in spring, and some of those early soil loss events in May through July, whereas at site 2 we saw a little bit in fall, and then again during that large rain event that we had in July. So to cover some of the main points that we're really seeing in that in our first 2 years of monitoring at the Antigo Flats is that they can be prone to high runoff, especially during snowmelt. Again, we are seeing some very, very high runoff values. high snowfall, and sometimes we do get that ice crust that forms below that snowpack and can really seal those soils up. We did see greater runoff, soil and nutrient loss observed in that new alfalfa as compared to potato, and also as compared to that well-established alfalfa. And in the new seeded alfalfa, the soil nutrient losses were near the Discovery Farms median. Potato or established alfalfa were lower, again, in these first years of monitoring. And again, the big picture thing that really was amazing, at least to me, from these first two years of data collection, were how low those phosphorus values were, considering the amount of runoff that we had at both sites, and the relative soil test phosphorus values that we have at both sites. So pretty neat data. That's why we do the research. One of the things that we're also excited to talk about is the fact that we added a third site in the fall of 2020, so that we will have 3 sites to compare in our next year of data in the Antigo Flats project area. So with that, if you do have questions, concerns, or just want to talk more about the data that I've shown here today, please feel free to contact myself or any of the other Discovery Farm staff, and you can have my contact information here, or you can find it at our website. Thank you very much and have a great day.